Introducing Colin Creed. Colin has been involved in tattooing since 1975. He's been retired for quite a while now, but come back in the last 5 years or so to build tattoo machines and get involved in the industry again. He also takes time to mentor a few tattoo artists and other small involvements in the field. Colin started tattooing in the mid-1970s. By 1979, he started to work professionally in the field. Those times were very different for the tattoo industry in Australia. The American suppliers hadn't yet appeared to the Aussie market, and to a large degree, as an Australian tattooist, you had to build your own equipment by hand. This is due to the fact that unless you were working professionally in the field, you never got a chance to get anything from the Australian suppliers. That meant you had to build everything yourself. With Colin's background in jewellery, it meant that he had the abilities to work with metal. Colin also had a fair idea of electronics due to his father's background, so Colin would pick his brain on any electrical elements he wasn't too sure about. As a tattooist, you'd come into the industry with elements of your background trade or any previous experience. With that knowledge in jewellery, Colin built upon that information. Colin still builds tattoo machines today, but he does them very differently, outsourcing laser cutting to save time and keep his machine strong and consistent. The machine that you're seeing here is the style that Colin always built in the day. It's his favourite. Unfortunately, it's very time consuming to build like this, but he decided to build this machine as the final machine of its kind and document the process. Day 1. Preferring to work with steel due to the strength that it carries, Colin starts with steel straps. He wants to emulate the old school technique that was done in his day, where most people would have access to oxyacetylene, which means one would be used to fusion welding, brazing, and working with steel. With those skill sets and that kind of equipment, the idea was that using simple tools such as a hacksaw, vise, files, and other basic equipment, Colin would create his machine the way that he would have done in the past. This particular style was an easy way to build machines. You could use steel strap, and it was only a case of heating, bending, cutting, filing, and simple metalworking elements. Colin perfected his own style of machine that's based on a particular look. They're referred to nowadays as a bulldog machine, so Colin likes to call his adaptation the Hugo, named after an Aussie bulldog that he owned. This style is well known. Sailor Jerry had a similar style to this, and some of the American suppliers also had a similar looking frame, so there's nothing unusual about it. The process itself can vary quite a lot though, again depending on the background of the machine builder. But in effect, these would be done at home, in the garage with basic tools, and that's what Colin wants to emulate here. The reason why this is the final build is not only because they're so time consuming, but also due to Colin's fading eyesight, which makes it increasingly difficult to keep his machines consistent. Colin uses fusion welding. He likes to cut and file to create the bends because it produces a tighter and neater seam where the bend point is. Some artists put the strap in a vise and just bend it, and that's fine, it works for them. Having the jewellery background, however, Colin is used to different thicknesses of metal, and in this case, he'll actually cut a recess and then bend, so that it's nice and clean. Then he'll fusion weld, as steel on steel will give a stronger weld point. This will then be filled later on with brazing. Day 2. In the case of this machine, Colin is working between a grinder and a file. The grinder that he's using today is what's known as a linisher, or a linishing machine. He uses the coarse belts as opposed to fine ones, which means they remove the excess metal and materials quickly, and then the roughness will be removed by hand with a file. These are the main components of the frame: the quick change element for holding the tube in place, the main body of the frame, and the sidearm. Colin tries to build his frame in sub-assemblies. The first element to go onto the main frame will be the quick change. Colin also builds the sidearm as a separate element, which allows him to make it square and check all the dimensions, which he then fits to the main frame where he wants it. In some cases, the sidearm's position in relation to the frame and the tube can make a machine run very differently. It's almost like you're creating two separate machines. So for repeatability, Colin builds these pieces separately so that he can do fine adjustments, weld it into place, and then do extra adjustments if he needs to. Sometimes force is necessary, but for Colin, he prefers to use heat and finesse to get the outcome that he wants. With the steel points and voids cleaned, Colin applies a flux to the frame. This allows him to get into the corners easier when he's brazing. Colin's measurements are based on elements from other machines that he's created and owned. A machine or a particular style of machine might work really well for a particular purpose, and in doing so, you then use the old machines as your reference point, taking measurements and working it out. Sometimes it can be as simple as that you started out life with your handmade machine. In the process of that, you realize that it's not up to your standard. You then start to work out what some of the problems are, closing up gaps for example, or making minor adjustments to suit your needs better. You might start to buy certain coils from a supplier and find out that they didn't fit another supplier's frame. So you'd have to make your own frame that allows for these coils. This is how you start to create your own measurements and your own style. This particular hole is going to be for the stud. That will hold the clamp that forms the quick change, which then holds the tube in place. With drilling, especially once you get into thicker metal, it helps to lubricate while you're drilling. In this case, a little bit of oil is placed on the steel to help the drill cut through. The next step is to test the threads and ensure the screws wind in correctly. Now shown is the final steel frame and the steel straps it was built from. Day 3. The next stage is assembly, but in between finishing the frame itself and the assembly, the frame went to a process called black oxide. It's not a process Colin can do in-house, so he sends it off to a commercial business who does that for him. When it returns, he starts to assemble the tattoo machine. The coils have a coating on the wire that needs to be removed where you're going to solder them to lugs or other elements. You have a top and a bottom coil. Colin's already established which one is which and prepares his wires by scraping the shellac covering off the wire. Because Colin is building the machine how he used to, he's chosen to use a supplier that he used to in the old days. The reality is, he can make his own coils, but he can't get the power and quality of punch out of handmade coils than he would from these particular ones. The supplier still makes the same coils in the same way as what they would have done 30 years ago. And it's the same quality as if they were from back then also. This particular customer wanted a machine with a dual connection, which in this case is a clip cord and RCA. Colin had to create a bracket in order to work out the electrical elements to go into his machine. Given that this machine is hand built, he has no templates for some of those pieces. So he'll trial and error and ensure everything fits together. He checks the alignments, measurements, and for any interferences that might occur during the assembly. He now solders the pigtail wires from the coils, which need to be insulated with wire tubing. The wires coming off the capacitor aren't long enough to reach back to the point where they need to attach, so Colin extends the pigtail wire by soldering another piece onto the existing wire. With the coils positioned, he can now fit the last of the electrical connections and then start to finish the build by adding binding posts and the final elements. The bottom binding post is already positioned. That's where the clip cord attaches. The top binding post is what provides the power through contact to the spring. Once Colin has the top binding post in place, he likes to ensure that the pigtail wires are all nicely positioned and make sure they won't disrupt the fitting of the armature bar. He likes the wiring to hug the frame as tightly as possible to keep it clean, functional, and tidy. The less obstacles you have, the less chances of catching a wire on your gloves, clothing, or anything else. With the top binding post positioned, Colin fits a tube blank into the machine. He'll then look down the side of the tube to double check that the contact screw is aligned to the tube. If the screw isn't aligned in the center, he'll use shimming washers to space it back into alignment. The fitting of the armature involves attaching springs. Colin hand makes his own springs using his own method of cutting and filing, fine-tuning them into fitting the frame correctly. Colin doesn't use any jigs or templates, just a pair of pliers to lock the springs together while he does the armature. Having put the springs onto the armature bar, the next stage is to add tension to the springs by bending them. Colin is aiming for a smooth, flowing bend in the springs. If they have any kinks in the bend, they'll crack much easier. It takes a little bit of tweaking with the preset on a spring gauge to fine-tune the tension of the springs. Colin thoroughly enjoyed this build, but was quickly reminded of how long they take to create. Even with his love for the process, he's glad to see the end of this particular machine. With the end of this process, Colin has a newfound appreciation of his new machines, their process, their speed and consistency. Rather than building all of his machines this way,